In this video recording, I will explain how to calculate integrals with a parameter. For example, let's take a look at the following integral. Integral of x squared e to the power x times y dy. The integral here ends with dy, and that indicates that the integration is performed over the y variable. In a sense, y is the true variable in this integral. On the other hand, x we treat as a constant, the value of which has not been specified. To see how to calculate this integral, it is useful first to compute this integral for a specific value of x. So let's assume, for example, that x is 2. Since we treat s as a constant, suppose first that x is equal to 2. Then we can plug in the value of x in our integral. Right, so I'm going to rewrite this integral, and everywhere I see x, I'm going to replace x with 2. So integral of 2 squared times e to the power 2y dy. In other words, this is the integral of 4 e to the power 2y dy. And then we can proceed to compute this integral in the usual way. You probably will recognize here that we can make a substitution, taking the exponent 2y to be equal to, let's say, to be the new variable t. Okay, so we'll make a substitution, 2y equals to t. To complete the substitution, then I will have to calculate dy in terms of dt, express dy in terms of dt. Differentiating 2y equals to t, we get dt equals 2 dy. Note that in our integral, we have the constant 4 times dy. When I compare this with dt, which is 2 dy, I see that the easiest way to complete this substitution is to note that 2 dt is equal to 4 dy. And so in our integral, 4 dy is going to be replaced with 2 dt. And so we get integral of e to the power t, this is e to the power 2y, times 2 dt. And of course here it is easy to complete the integration. 2 is a constant, which we can pull outside of the integral, and the antiderivative of e to the power t is just e to the power t. So we get 2 e to the power t plus a constant, and then going back to the original variable, replacing t with 2y, we'll find 2 e to the power 2y plus a constant of integration. Okay, so this is, we basically computed the integral that we started with, but just for one specific value of x when x equals to 2. The calculation of the integral for any other value of x is going to go very similar. And in fact, the calculation of the integral with x in place of a specific number will also go very similar. And you can take this calculation that we just completed as a guiding example to finish the calculation of the integral in general. Okay, so let's now complete the integration of the original integral. We're integrating x squared e to the power xy with respect to y. And again, we're going to make a substitution, and we're keeping in mind that x is a constant, possibly x equals to 2, maybe 7, maybe -1, maybe some other number. And so we're going to make, just like we did earlier, we're going to substitute x times y equals to t. Okay. And so that's going to be our substitution, t equals to x times y. Again, to complete the substitution, we need to express dy in terms of the new variable, t. So compute dt. And when I compute dt, I keep in mind that x is a constant, so dt is the differential of x times y, but because x is a constant, this will turn out to be just x times dy. Now, looking at our integral, we see that our integral contains x squared times dy. And when I compare this with dt, which is x times dy, I can now see that x squared dy is going to be equal to x times dt. I basically multiplied the previous line by x. Okay, and so this then allows us to complete the substitution and rewrite this integral as integral of e to the power t times x dt. And again, we treat x as a constant. We can pull it outside of the integral. And of course, again, antiderivative of e to the power t is e to the power t. So we get x times e to the power t plus c. Now here, a slight subtle point is that in the previous example, we could finish and write that our antiderivative, our integral, is 2e to the power 2y plus a constant c, and just that. But here, when we add a constant c, one subtle fact that we should keep in mind is now that this constant c may be different for different values of x. It doesn't have to be the same. So for instance, if x equals to 2 and we happen to use the constant 5, for example, then when x is -1, we don't have to use exact same value of the constant that we used for x equals to 2. And so this constant c may actually depend on the value of x. It may actually be a function of x. So that's for that reason, it's better to write our result of this integration as x times e to the power t plus c of x. And of course, I have to go back to the original variable and substitute instead of t x times y. So our final result is x times e to the power x times y plus some constant c of x. Some constant c which depends possibly on x. Okay, so this is the process of integration with a parameter, and it will be a very important step in computing double integrals, which we will take a look at in a later video.